This is section 7.4, looking at similarity when there are parallel lines in triangles and looking at proportional parts. Triangle proportionality. A line that intersects two sides of a triangle in distinct points is parallel to the third side if and only if it separates these sides into segments of proportional lengths. Here's what that means. Let's say that this segment is parallel to the third segment. Third segment being the side that it doesn't touch. So for that to be parallel, let's label the lengths of these sides as W, X, Y, and Z. So if and only if, this is a symbol for that, which means we can read this left to right or right to left. These four segments must be broken apart proportionally. So that means W to Y is going to be the same as X to Z. There's different ways to write this proportion. This is one of the ways to do it. So let's examine this a little bit closer. What did W and X have in common? They're on the same segment. W and X are on the top of this fraction. What does Y and Z have in common? Well, they're also on the same segment. They're on the bottom of the fraction. Well, what does W and Y have in common? Well, they're in basically corresponding positions on each side of the triangle. And what does X and Z have in common? They're in corresponding positions of the triangle. So you can write this proportion any way you want, but not any way you want. There's lots of correct ways to write it. Let's just say that. The easiest way to write it, in my opinion, is just look at your picture and just make your proportion. That's what's happening here. W over Y equals X over Z. Mid-segment. A segment in a triangle with endpoints that are the midpoints of two sides of the triangle. So pick two sides of the triangle, find their midpoint, connect those midpoints, and that's called a mid-segment. Theorem. A mid-segment is parallel to the third side of the triangle and its length is 1/2 the length of the third side. So let's find midpoint here again. I'm going to label some endpoints here. So the mid-segment which is AB, is 1/2 the length of the third side. The third side's XY. It also says that segment AB is going to be parallel to segment XY. A mid-segment is parallel to the third side, and it's 1/2 the length of the third side. Corollary, 7.1. This corollary is essentially the triangle proportionality, but it's got more than two parallel lines. So let's label some of these parts. Let's say this is A, and this is B, and this is C, and this is D, and this is E, and this is F. So A is this segment, B is this segment, C is this segment, D, E, and F. The corollary means that this is so closely related to a different theorem or postulate that it's basically saying the same thing. And I should mention up here, triangle proportionality, this is a theorem. Somehow I missed that word in the notes here. So this corollary, 7.1. If 3 or more parallel lines, and we have 1, 2, 3, 4 parallel lines, intersect two transversals, so here's 1, 2 transversals, then they cut off the transversals proportionally. So here's what that means. The length of A over B is going to equal the length of D over E. Another proportion that you could say. B over C is the same as E over F. Would have been better in hindsight had I labeled the vertices of this. I'm going to do that as well here. Let's say this is X and this is Y down here. And let's say this is Z and this is W. Completely illogical how I did that. Deal with it. Let's say also that this right here is a Q and an M and an N and a V. Each of these points that I'm naming are a point of intersection. So some more equations that I could write, proportions. I could say that XZ, that's this length here, over, let's say, WZ is going to be equal to, over on this other transversal, the corresponding part would be MN over the part that corresponds here to WZ would be MM. I messed that up. My apologies. I've got XZ and QN. I've got WZ and MN. There's lots of proportions you can write from this, but it's important to know that you must have a relationship this way, and in this case, these are corresponding. You must have a relationship this way, and in each case, these are on the same transversal. Hopefully this will make more sense as we do examples. Corollary 7.2, which is basically Corollary 7.1 in a more specific case. If three or more parallel lines, we've got those, are cut off segments on one or more transversal, we got those as well. I said that wrong. If three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on the other. So that means if this and this and this are congruent, then that means these also have to be congruent. Let's check out some examples. Number one, find the value of x. Well, if I use the triangle proportionality theorem, just to the left of this in my notes, here's what that tells me. I'm just going to read it. A line that intersects two sides of a triangle in two distinct points, so that's this one here, just intersecting these at two distinct points, is parallel to the third side, which the picture shows that. Then it says if and only if. So if it's parallel to the third side, then the following is true. And that's that these sides, which is this, 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 and this, are separated into proportional segments. That means I can write a proportion 10 is to 12 as 7 is to x. Then to solve this, I'm going to multiply both sides of the equation by 12x. On the left, the 12's cancel. On the right, the x's cancel. Gives me 10 times x equals 7 times 12. So 10x is 84. Then I can divide both sides by 10. Get 84 over 10. I can divide those both by 2 and get 42 over 5. So x is 42 over 5. That is a direct example of the triangle proportionality theorem. Number two, determine if BD, that's this segment, is parallel to segment AE. Well, for those to be parallel, it must cut off this segment and this segment proportionally. Let's see what information we're given. CA is 15. AB is 3. CD is 8. CE is 10. Using the segment addition postulate and no work, we can conclude that this here has to be 12, because 12 plus 3 is 15. In a similar sense, we know this is 2, because 8 plus 2 is going to give us 10. So to determine if these are parallel, we have to do the following. We take a proportion, 12 over 3 equals 8 over 2, and we decide, is this a true statement or is it a false statement? If it's true, according to the triangle proportionality theorem, then these lines are parallel. If it's false, then they cannot be parallel. Both of these reduce to 4. Therefore, since that's a true proportion, segment BD is parallel to segment AE. On the flip side, find the value of x. Now this is related to corollary 7.1, which says, if 3 or more parallel lines, and we have 3 in this one, intersect 2 transversals, so this is one of our transversals, this is the other, then they, meaning the parallel lines, cut off the transversals proportionally. So that means that we could take 2x over 36, and that must equal 4 plus x over 26. The nice thing about these transversal problems is this problem basically sets itself up. 2x is on top, 4 plus x is on top, 36, 26 on the bottom, yada, yada, yada. I'm going to simplify this fraction on the left just to make my number smaller. It's going to make it x over 18. Now I'm going to multiply both sides of the equation by 18 and 26 to try to get x by itself. I could actually use a smaller number for this, but I'm just going to choose these numbers. On the left, the 18s cancel, we get 26x. On the right, the 26's cancel, and we get 18 times 4 plus x. If we distribute the 18, see, 18 times 4, I believe, is 72, plus 18x. If you subtract 18x from both sides, you're going to get 8x equals 72. And if you divide both sides by 8, you're going to get x is 9. So I think that works out. Once again, I'm not great with numbers, but the process here is correct. Number 4. Find the value of x. Now this problem is actually incredibly simple if you know your theorems. We had a theorem on the front of our notes called the Theorem 7.6. I'm going to call it the mid-segment theorem. Probably would have been smart to do that. Let's go back in our notes. Let's call this Theorem 7.6. Let's call it the mid-segment theorem. That sounds like a good idea. So according to the mid-segment theorem, first of all, this is a mid-segment because it bisects both of these sides. According to the mid-segment theorem, that mid-segment is parallel to the third side and it's 1/2 its length. So that means that x is going to be half the length of the third side. Therefore, x is 7. Pretty easy to do if you know that theorem. 2 more. Find the values of x and y. Well, this is corollary 7.2. If you need to look at that, you can. That's the bottom left of the previous page. That says if you have 3 or more parallel lines, which we do, 1, 2, 3. Actually, we got 4. And if one transversal makes equal segments, which it does, then that means any transversal is going to make equal segments. So that means that these are both 8. So x is 8 and y is 8. It does not mean that these segments are 8. Does not mean that. But it means all the ones down here have to be 8. So for example, these could all be 4s. Don't know what they are, but they don't have to be the 8s. All right, last problem. Find the value of x. Well, if we go back to the triangle proportionality theorem, since this segment here is parallel to this third side of this triangle, it means it cuts off the triangle, these two sides here and here proportionally. So we need to know what the length of this is. Well, if the whole length is 16, and we use part of it here as x, it means this is going to be 16 minus x. That is the segment addition postulate. So we can say, using the triangle proportionality theorem, that x over 16 minus x is going to equal x plus 4 over 12. If we try to solve this, we can multiply both sides of the equation by 12 and 16 minus x. On the left, 16 minus x's cancel. On the right, the 12's cancel. On the left, we get 12 times x. On the right, we get x plus 4, that binomial, times the binomial of 16 minus x. Yes, the parentheses matter. I'm going to bring this whole thing down here where I have more space. You can draw an arrow if you want to do the same. It's going to give me 12x equals. I have to multiply the x times both of these terms. Got to multiply the 4 times both of these terms. If I combine like terms, I feel like I made a mistake here. Should be at 16x. Yeah, forgot an x there. If we get all the terms on the same side, I want to get them on the left because I don't want things being negative. Let me first simplify the right side. 16x minus 4x is a 12x. If we add x squared to both sides, ooh, this is nice. If we subtract 12x from both sides, it cancels. So we end up with minus 64 equals 0 if I bring everything to the same side. I thought I was going to have to factor. Turns out I don't have to factor. I'm going to put the 64 back over here. If I then square root both sides, I get x is plus or minus 8, because the square root of 64 is 8. Anytime you take an even root, you need to do plus or minus. When you do that, you might get a false answer. So let's see if one of these answers doesn't make any sense. So right now we think our answer is either going to be a negative 8 or a positive 8. Maybe it's both, maybe it's neither. If I put a negative 8 in here for x, I get the length of that side of the triangle is negative 8. That makes no sense. Therefore, x can't be negative 8. If I put a positive 8 in to this, I get 12. Here I get 8. Here I'm going to get 8 as well. So it turns out this has one answer. X can't be negative 8, so x must be 8. That concludes the notes. Please do section 7.4 homework.